Okay, there's the whole circuit for this pulse inverted Joule thief that I've been working on a lot. And today I got around to doing what I was supposed to do earlier in the week, and that's change out the 555 chip. It's called a 555CN timer chip to a low power timer chip. It's a TLC 555. They also call it a CMOS, CMOS timer chip. It works on a lot less power, and what we don't want to do is we don't want to eat up the energy turning on the Joule thief and turning it off. So it was Paul's idea to go ahead and change that out, and he's already got it done, I'm sure, but he hasn't posted it yet. But I had a chance today to do it, and it does make a difference, and we just got to figure out some way not to fry it by running the big stuff over here. So I've got to figure out some way to protect that, because it's a very low power device. Now this is the other one. It's a little 555 timer chip, integrated circuit, and this is the low power one, and that's it right there. It looks identical. You can't tell them apart. But take a look at that. That's not even showing up on my meter. That's 000, which means it's below 10 milliamps on the draw. Now I'm driving the timer circuit, and I'm also firing off the small Joule thief right there. That's the little one LED, and that's the small Joule thief circuit that I actually can run on super caps. And that's what we're looking for right there, guys. We're looking for a see if I can get this to slow down a little bit for us here. We're looking for a waveform that is pulsed at the top with these spikes up there, and then off at the bottom. And it all comes down to how much light you can get for how much power you're using. And those little jiggy jags are when the Joule thief is actually firing, and the one at the bottom is when the Joule thief is turned off. So it's off, it turns on, it runs for a little while, and then it turns off. And balancing that thing out gives you the light for the low power consumption. And that's what we're working with right now. And on that circuit there's a potentiometer for the pulse width, that's this part here, and then there's a potentiometer for the frequency, which is how often that goes. But anyway, I just wanted to show this, and this is what Paul has been working so hard on. Kubikop is this pulse width modulator circuit to drive the Joule thief, and that's what we're after, those low numbers. And if I can get that to go into here to run this, it's going to save us energy, and that boils down to efficiency, and that's what we're all after. But normally these timer circuits can eat up to 30 milliamps depending on how you're driving them, but you can see this is under 10 milliamps, and it is driving a Joule thief right now. So I just want to let you know what's going on, and I'm going to slow this down here. You'll see this start to blink. And that's the oscillation, and you can see up here on the scope it's lengthened way out. And I'm going to speed this up here, and there it goes into that waveform that we want. It's a square wave, what they call square wave, and that's when your eyeball can't see it blinking, but it's actually blinking, and that's on part of the time and off part of the time. So anyway, that's what we're going for with those kind of numbers.